Alright, section 7.2, adding and subtracting rationals. Once again, a lot of parallels to fractions. A lot of parallels to fractions. So, if you remember how to add fractions, this will be very, very easy. So let's start with how to add fractions. When we multiply and divide, you just go straight across, right? It's very easy because you're just multiplying by, numerators and denominators together. However, when you're adding things that are not quite whole numbers, you can't add things of different sizes, right? If you're trying to add 2/3 of the pie to 3/4 of the pie, well, it's now 2/3 and 3/4, right? So you need to be able to put them into similar pieces to see how much you've actually added together, right? So we need to find something called the LCD, or the LCM, based off who you're talking to. The LCD is the least common denominator, and the LCM is the least common multiple. They're essentially the same thing. It's just a denominator is actually located within the fraction. Okay, so let's do that with a few fractions, and then we'll do it with a few polynomials. So, the least common denominator here, between 1/4 and 1/2. Well, let's take a look at it. Well, the denominators here are 4 and 2, right? Let's find the least common multiple of these guys. Well, 4 has 4, 8, 12, 16, ... Those are all the multiples, right? 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. 2 would be 2, 4, 6, 8, 12. Careful, I'm not looking at factors, right? I'm not looking for the greatest common factor. I'm not looking for what does multiply. I'm looking for the multiples of, right? It's kind of different. All right, now we want the one that they have in common. That is the smallest, hence least common multiple. That would clearly be 4. They have 4 in common. So their least common denominator would be 4, right? Just for, giggles, let's take that and so the least common denominator would be 4. Let's change both of these so that they are in fourths, right? Well, lucky for us, 1/4 is already a fourth. So 1/4 is already a fourth. Sorry. 1/2. Let's see, how can I get 1/2 into fourths? Well, I need to multiply the bottom by 2, right? And if I multiply the bottom by 2, I have to multiply the top by 2. So that would be 2/4. Now they match. I can clearly see that when I add them, they're 3/4. Let's do it again. So I need to find the least common denominator between a denominator of 18 and a denominator of 12. Let's take a look at those multiples. There's 18, 36. Oh. So 18, 36, 54, ... And then the same thing for 12, 12, 24, 36, ... And I know I can stop there because I found the first one they have in common, right? You want the least. There's no point in me going any farther. I found one they have in common. So unfortunately for this one, if I wanted to change these to be similar, it looks like I have to actually change both of them. So this first one, 18 to get it to 36, that was times 1, 2. So this would be over 30. So this first one would be over 36. I had to times the bottom by 2. So now I have to times the top by 2. Same thing over here. I had to multiply this 1, 2, 3 times. So this one's also over 36. Since I multiplied by 3, I have to multiply the top. I get 3. And then if I added those, clearly I would get 5 over 36. Well, let's do it again. Just one more time. We'll do it 2 more times. So 37 and 3. Interesting. All right, well, 37, that's okay. Just got to find those multiples, right? 37 times, so we got 37, right? And we've got 74. Oops. 37 times 3 is 111. And then we've got quite a few 3's. So ... 3, 6, 9, ... And I'm going to tell you, the first thing they have in common is 111. 111 divided by 3 is 37. So sometimes their least common multiple is actually the multiplication of the two denominators. Sometimes that is the case, especially if they're both prime. Like these guys are both prime, right? They have no other factors besides one in themselves. It's not a guaranteed rule, but most of the time, it's going to be the thing they have in common. So their multiplication together. So I can put both of these over 111. Now when I multiplied the 37 to get it to 111, that was 1, 2, 3 jumps, right? 1, 2, 3 jumps. So I have to multiply 3 on the bottom. I got to multiply 3 on the top. 3 times 2 is 6. Let's see, 3 to get to 111 was times that by 37. So now I've got to multiply the top. 4 times 37 is 148. And so now I can add those two together, right? So sometimes the least common multiple is their actual multiplication. Test that out if you think it's going to take a long time. Sometimes it just takes practice though. The last one, hopefully this is starting to make sense. I've got a denominator of 4 and a denominator of 6. Let's see, we've got 4, 8, 12, 16. I've got 6 and 12. Oh, there it is. The least thing they have in common is 12. So now I have it both over 12. In order to get a 4 to a 12, I had to multiply by 1, 2, 3. So multiply that by 3, multiply the top by 3, it's 9/12, right? And I can always double check. If my increased fraction, right, going from 3/4 to 9/12, doesn't reduce back to 3/4, I've made a mistake, right? But if I were to take 9/12 and reduce it, I would divide them both by 4. I would divide them both by 3, and I would get 3/4, right? So if they aren't interchangeable, you might have made a mistake. On the second one, I had to change a 6 to a 12, which I times by 2. So I'll have to do that to the top. 1 times 2 is 2. And I end up getting 11/12 when I add them. Okay, so that's least common denominator. We're going to do the same thing for variables now. Again, this chapter really should be called Fractions with Variables, because it's the same thing. We're going to find the least common multiple between the two. However, least common multiple looks a little different when you're looking at variables because you don't actually know the factors, right, or the multiples, right? If I don't know what x is, I don't know what x times x is. I don't know what x squared is, right? But I do know that if I have x squared, that's the same thing as x times x, right? And I do know if I have x cubed, that's x times x times x. If I have to have a minimum, right, if I have to have a minimum, or a minimum this time, I need to have at least the one that's the biggest, right? The one that's the biggest. Otherwise, it doesn't work, right? In the first example, we needed to have at least 4. Otherwise, they weren't going to have anything in common. I couldn't have 2 because 2 is not a multiple of 4, right? 2 is a factor of 4. It's smaller than 4. There's no way that's going to be the multiple if it's smaller than that, right? So same logic here. I need to have at least as many as my highest power. So at least as my highest power. Therefore, my least common multiple would have to be 3, right? So I'm going to have at minimum 3 in both of these guys. So I'm going to have to multiply the second guy by 1 to get x cubed, and I don't need to multiply anything to the first guy. In other words, my least common multiple would be x cubed. Okay, same thing over here. Least common multiple. Well, I've got now 5xy squared, 2x cubed y, right? So I want to find the common multiple between the two. Least common multiple between 5 and 2 is going to be 10. So the LCM is going to be 10. That's the first multiple they have in common, right? 2, 4, 6, 8, 10, 5, 10. X, I need the highest power. At least 3 x's. Need at least 3 x's. Y, I need the highest power. At least 2 y's, right? 2 y's. So there is my LCM. Cool. Right, because it's basically what's the smallest multiplication of the two, right? What's the smallest number they have in common? Well, no, that's a bad way to think about it, because that's greatest common factor. But least common multiple, you should be going up. Multiples, greatest common factor, you should be going down. All right. Let's do this one. Let's do this one first before we go talk about C. All right, so least common multiple between 24 and 18. Well, let's see. 24 would be well, 24, 48, 30, not 36. 24, 48, 72. Okay. 18 would be 18, 36, 54, 72. 72. Okay, so the LCM, I'm going to write it up here, would be, not in that color's ugly. 72, and then the highest A would be A to the 5th. The highest B would be B to the 4th. Alright, LCM of 72, A to the 5th, B to the 4th. Okie dokie. Hopefully that makes sense with monomials, right? Monomial is one term, just one single term. So you want the highest power. When you have something like what's happening in C, you have a monomial and then you have a binomial, right? You have one term and then you have two terms. Remember, we're not dealing with things in terms here. We're dealing with things as whole polynomials. So just like when we were multiplying or dividing, right? We had to think of it as a whole enchilada, a whole all or nothing situation. So here, the least thing I have in common between them, the least multiple I have in common between them would be their actual multiplication. The LCM is going to need both parts. It's going to need a k times a k minus 3. So it needs both parts. You're welcome to multiply it out. Say it's k squared minus 3k. For our chapter's purposes, though, you actually do want to leave it like this. So this would be the best answer. In other words, an LCM is going to have one of each. Just like in this example up here, the first thing they had in common was their actual multiplication, right? Same thing goes for their variable. The first thing they have in common is the actual multiplication, k and k minus 3. That's the only two ways they have things in common. All right, let's apply that same logic down here. E is a little different. We need to factor E first, if we can. We need to factor E first, because we don't know what they already have in common. Maybe they both have a factor of y plus 2. If they did, we wouldn't need to say it twice. We only need it once. So let's get this down into lowest terms. Let's take these into factored form. So let's start with y squared minus 2y minus 8. All right, two things that multiply to negative 8, add to negative 2. Well, 4 and 2 are sounding good. Looks like negative 4. So this factors into y minus 4 and y plus 2. Okay, so that was my first polynomial. Now I'll do the second one. Second one says y squared plus 3y plus 2. All right, y squared plus 3y plus 2. Two things that multiply to 2 and add to 3. I'm thinking 1 and 2. 1 and 2. So y plus 1, y plus 2. And again, I just used the trick because I noticed y had an a of 1 on it, right? Again, check out 6.2 if you don't know what that means. All right, now between these two guys, they definitely have something in common. In fact, it does turn out to be a y plus 2. That's actually a coincidence that I said that before. They already have a y plus 2 in common, right? So just like here, this guy had a 4 in common. One was already a 4. We don't want to change the 4, quote unquote, right? So the LCM here, let's just kind of cut that off so you know which part we're talking about. The least common multiple here is going to already have a y plus 2. It's only going to have one of them because we don't need to. We don't need multiple, right? We don't need multiple of them. But the blue guy is missing the y plus 1. So we're going to need to add a y plus 1. And the pink guy is missing a y minus 4. So we're going to need a y minus 4. So that would be the least common thing that would make those two exactly the same. All right, cool. Well, let's try it again. Basically, in other words, only take one of things you have in common. Take one of each, really, one of each. If you have two y plus 2s, do not take both of them, right? Just take one of each. That'll give you your LCM. Let's do it again. I've got y squared minus 16, y squared minus 8y plus 16. So let's start with the y squared minus 16, right? That's a special case. So I know that factors into y plus 4, y minus 4, right? Again, 6.3, special cases. The second one is y squared minus 8y plus 16. Y squared minus 8y plus 16. Okay, Two things that multiply to 16 and add to negative 8. Let's see. That also kind of sounds like a special case to me. I think it's negative 4 and negative 4. Yep, this is a polynomial squared. So I've got a square and a square. This middle part is 2ab, 2 times 4 times 1. So this factors into y minus 4, y minus 4. Alright, what do these guys have as a least common multiple? I take one of each binomial. One of each binomial. I have a y plus 4 and a y minus 4. Over here, I already took one of the y minus 4s, but I need the other one. Y minus 4. So that would be my LCM. Now, be careful. Be careful. Up in the last problem, they each had a single y plus 2. A single y plus 2. They both had it, so I don't want to double, but they both had one. And so we only wrote one down, right? Here, this lighter blue polynomial had 2 y minus 4s, okay? So in my LCM, I needed to have 2 y minus 4s. If you have doubles within one polynomial, that's different than them sharing a factor. You see what I mean? This guy has 2 already. He needs to still have 2 in the LCM. He only has 1, so they only have 1. You don't need to write 3 of them down. You just need to write 2. Okay, I hope that makes sense. Oops. Oh, that was this problem. Okay, so that was that one. Let's do the next one. Let's do G. I have 8z minus 24 and 5 minus 15z. This one is nice because it's not quite square. It's not quadratic. We're still going to factor it out, though. So 8z minus 24. That's the same thing as if I take out an 8, I get z minus 3, right? Here I have 5 minus 15z. Okay, let's take out a 5. We get 3 minus 5z. Nope, just kidding. We take out a 5. What am I doing? We get a 1 minus 3z. Yes, 1 minus 3z. Alrighty. These guys don't have virtually anything in common. Virtually anything at all. That's okay, right? That's okay. It just means their LCM is going to be one of each. So 8 z minus 3 and 5 1 minus 3z. Alright, this problem was trying to be super tricky, making those look very similar, but since the z is in the other part, right, it's definitely not the same thing, right? But we're smarter than that, so we didn't fall for the trick. It's one of each piece. Let's do another one. Okay, so I have s squared minus 3s minus 4. Let's factor that guy down. S squared minus 3s minus 4. Let's see, two numbers that would multiply to negative 4 and add to negative 3. That would be 4 and 1 are sounding good. Probably negative 4 and 1. So this guy would factor into s minus 4 and s plus 1. While this guy, let's see, that a times c would be negative 6, adds to 1. That would be the two numbers of 6 and 1, probably be 2 and 3. Probably 3 and negative 2. 3 and negative 2. Alright, this one I actually have to do grouping on because the trick doesn't work, right? It's not a equals to 1. So I have to do 3s squared plus 3s minus 2s minus 2. I gotta remember when my tricks actually work, right? So I have 3s and s plus 1. Pull out a minus 2, s plus 1. It looks like this guy is 3s minus 2 times s plus 1. Alright, let's take a look. They have in common an s plus 1. That's awesome. Means I don't have to write it twice. So s plus 1. And then 3s minus 2 and s minus 4. 3s minus 2, s minus 4. There's my LCM. I took one of everything. One of everything. I didn't double up on stuff they shared. I just took one of everything. Okay. Last one. m squared plus 5m plus 6, m squared plus 4m plus 4, 2m squared plus 4m minus 6. I've got 3 factors here, but nobody ever said anything about that being a problem, right? It's not, it doesn't have to be binomial times binomial or anything like that. I just need to see what they need. I need to take one of each of their factored forms. So we will first factor this, okay? M squared plus 5m plus 6. Let's see. That would be 2 and 3. M plus 2, m plus 3. M squared plus 4m plus m, that would be, let's see, multiplies to 4, adds to 4, that would be 2 and 2. So m plus 2 and m plus 2. This last one, I see a GCF of 2, so I'll take out a 2. I get m squared plus 2m minus 3. And, oops, let's do this in a different color. 3, so take out a 2, you get m squared plus 2m minus 3, right? And then m squared plus 2m minus 3. So two things that multiply to negative 3, add to 2. That would be 3 and negative 1. So m plus 3, m minus 1, and a 2. Alrighty, their LCM is going to be 1 of each. So m plus 2, m plus 3. Let's do it in red. M plus 2, m plus 3. I already have an m plus 2, but it looks like I need another one. Times m plus 2, right? And the last one, I already have an m plus 3, but I do need a 2, and I need an m minus 1. There is my LCM. Lots of different factors, but that's okay. I got one of everything. Alright, hopefully the LCM is making sense, because we're now going to use it to add and subtract. Okay, we're going to add and subtract stuff. When we add and subtract, you just need to have a least common denominator, and then you add the numerators. Add the numerators. Let's try that with fractions. Let's remind ourselves how fractions work. So we have 1/3 plus 1/4, right? 1/3 plus 1/4. We need a least common denominator, or a least common multiple, right? So let's put a least common multiple between 3 and 4. 3 and 4. Well, 3 would be 3, 6, 9, 12. 4 would be 4, 8, and 12. Looks like it's going to be 12. Okay, in order to get the first one to something over 12. So I need to change both of these into over 12, right? That's way they match. That way they're equal pieces. That way I can actually see how many pieces I have. In order to get the first one to be over 12, I had to multiply it by 1, 2, 3, 4. So I'll multiply the top by 4. 1 times 4 is 4. Over here, I have the same thing. In order to get this 12, get the 4 to a 12, I needed to multiply by 1, 2, 3. So I'll multiply the top by 3. And now I just add the numerators. If I have 4/12 and 3/12, I have 7/12. And that's how you add two fractions. Fabulous. Let's do the same thing with some variables now. Well, these are not the best two problems because they're already in LCD form, but that's okay. They're LCD. These guys already share one. It's 5, right? So we already have two equal pieces here. We have a 3y fits, and we have x fits. So when we add these together, we just get we just get a new one of over 5. Just add their pieces together. We can't actually add y and x, right? Because we don't know y and we don't know x. But we have, sorry, I want to fix that equal sign. And I didn't do a very good job. That's okay. We have them both over 5 now. C is very similar. It's a subtraction problem though. When we subtract, it's the same thing. Remember that you can rewrite any subtraction problem as an addition problem of a negative number. So we can rewrite this like this and then just put them over the same fraction. And when we do that, we can actually reduce this one because the tops are just numbers. So we get negative 4 over 2r squared. And I can reduce it even more, negative 2 over r squared. Cool. Okay, so the idea here, as long as their bottoms match, you just add the tops, right? Same thing goes if it's rational or whole numbers. And if it's subtraction, you just change it and then add the tops. Same thing down here. We're actually going to skip these two because I feel like you guys get the point. However, if you're at home and you think you need extra practice, try it yourself. Alrighty. What happens though when they don't match? Well, when they don't match, we're going to have to do what we did in the very first problem. In order to get a 3 and a 4 to a 12, you had to multiply by something, right? So first off, what would be the LCM here? The LCM would be one of each, an R and an R minus 3. They have nothing in common, so that's my LCM, right? So at the end of the day, both of my fractions, I think I just chose the same color. That was weird. Both of my fractions should have R minus 3 on the bottom. That way they are the same quote-unquote size, right? They should both have 12, right? So they both have the same thing on the bottom. In the first one, in order to get 6R to have an R minus 3 on the bottom, and what I have to do is take 6R and multiply it by R minus 3 over R minus 3, right? What I do to the top, I must do to the bottom. Just like I multiplied 1/3 by 4 times 4 over 4, and I got 4 over 12, right? So I multiplied the top, multiplied the bottom. That's how I got my new denominator of R minus 3. On the top, I get 6 times R minus 3. In this case, I think I am actually going to multiply that in because I want to eventually reduce addition and subtraction. Since I'm not multiplying, I'm not looking for canceling, right? I'm adding. So I want to actually multiply that in. So 6R minus 18. The bottom I'll leave alone. You'll see why in a sec. Bottom I'll leave alone. Let's do the same thing for the second one. So the second one said 5 over R minus 3, right? Yeah. So, well, first let's change it to plus. So it would be negative 5 over R minus 3 times R over R. That's how I get my new R times R minus 3. Right? R times R minus 3. That's how I get my new denominator. I put the negative over there because it was a subtraction problem to begin with, so I'm actually adding a negative, right? So it's now negative 5. Then I multiply the top, I get negative 5R. Okay. So now I have my two new fractions being added. I'm going to write them in green. So I have 6R minus 18 over R times R minus 3, right? Plus negative 5R over R times R minus 3. Now they're exactly the same, so I can combine their numerators. 6R minus 18 minus 5R over R times R minus 3. Notice I did nothing with the denominator, just like we did add normal fractions, right? I did nothing with the bottom. I just wrote it out again, right? But the top I've now stuck together. And because I actually multiplied that out, I can see that I have a 6R and a 5R, negative 5R that are going to reduce. So I end up with, pardon my room, R, a single R, 6 minus 5 is 1, minus 18 over R times R minus 3. Again, I did nothing with the denominator. I just simplified the numerator. And I'm done. That's what it equals. So I just have to make a match in the bottom, and then add the tops. A little bit longer when you have to deal with a variable, but not that much more work. Not that much more work. Let's do another one. Let's do another one. All right, LCM here. They are not exactly the same. Remember that Q minus 1 is not the same thing as Q plus 1. So their LCM will be Q minus 1, Q plus 1. I need one of each. So the first fraction, I need to change it, right? I have 1 over Q minus 1. In order to get both of them on the bottom, I need to multiply by Q plus 1. What I do to the top, I must do to the bottom. Or what I do to the bottom, I must do to the top. So I end up with my new fraction as Q plus 1 over Q drag that down a little bit. Q minus 1 times Q plus 1. right? And we can see that if we wanted to go back, the q plus 1s would cancel, and I would get back to my original fraction of 1 over q minus 1. I'll do the same thing to the other one. I have 1 over, let me save some room for the final part. 1 over q plus 1. This time I need the q minus version. I need the minus version, so I'll do q minus 1 over q minus 1. That's going to give me q minus 1 over q minus 1 times q plus 1. Cool. Now I got two fractions that are the same in the denominator, right? Two rational expressions the same in the denominator. So I can put them over one larger fraction, and I can subtract them. Actually, I won't put them quite over one fraction yet. I'm going to need more room. You know what? Let's not do this one. We'll do that one later. Okay, so we're going to skip h. If you'd like to try it on your own, you can. Really, it's just a negative version. It's fine. So let's write this down here. I've got q plus 1 over. So q plus 1 over q minus 1 times q plus 1 being subtracted from q minus 1 over q minus 1 times q plus 1. They match in the bottom. Awesome. Now I can just change this from plus to minus, right? So I'm adding a negative, and then I see that I get q plus minus 1 for q plus 1, and I get, let's see, q plus negative q, that cancels out. 1 plus negative 1, I'm sorry, 1 plus positive 1 is a 2. And that's my final product. Alright, so, again, these just require room. They really don't require a lot of thought. What they require is that you figure out the LCM, right? What do they have in common? Least common multiple. And then you need to multiply it to both of them, multiply by what's missing, right? And then you can combine them because they'll be the same size. If they're the same size, quote unquote, then you can combine their numerators. Okay. This one, they are exactly the same, you just have to switch the sign. Oops, I'm deleting things that I meant to be erasing. Okay, so this one, the LCM here, we'll just talk about the LCM real fast, don't do the whole problem. Remember, these two are, in fact, negative versions of each other, so it's negative 1 times y minus 2. That's the only LCM. So you really only need to switch the second one. I'll leave you to figure that one out. Alrighty. Let's talk about a three-termed one, because, you know, why not? We can do that. Nothing's really different. Just gotta do a three-termed one. So, first off, let's find that LCM. LCM, it's gonna be, let's see, well, before I can do that, I have to get these in lowest terms, right? I gotta get these in lowest terms. So I've got x minus 2, definitely lowest terms. X, definitely lowest terms. This one, I'm gonna rewrite it as negative 6 over x times x minus 2. Right? Take out an x. Now can you see we have a lot of doubles here? So our LCM is going to be the first one, x minus 2, times the second one, x. And then if I look closely, that last one doesn't need anything, right? Both pieces are already there. This guy had an x, this guy had an x minus 2. So nothing's missing, so I don't need to write anymore. So that's actually my LCM, right? I don't need to write any doubles. Don't add doubles. Okay, good. Alrighty, so then let's rewrite this. The first term here, 3 over x minus 2. If I needed that to get to x minus 2 times x on the bottom, then I'm going to need to multiply by what's missing, an x. X over x. I'm going to do these all at the same time. The next one, I have plus a 5 over x. I need that to say x minus 2 times x on the bottom, right? So what's missing is the x minus 2 part. So I'll multiply by that on the top and that on the bottom. That on top, that on the bottom. The last one's not missing anything, so I don't need to actually multiply. I can just say minus x minus 2, right? Nothing's missing, so I don't need to multiply by anything. Now I can stick them all over 1 x minus 2, and combine their numerators. I've got 3x. You know what? I'm going to make this smaller because it's like huge. So equals x minus 2. Alright, in the blue one, I ended up getting a 3x in the numerator. In the pink one, I have 5 times x would be 5x. And then 5 times negative 2 would be negative 10. And then in the last one, I have a minus 6. Combine some like parts in the numerator. I have 3x plus 5x, that would be 8x. And then negative 6, negative 10 would be negative 16 over x minus 2. And that would be a fine answer, a beautiful answer, a complete answer, except for the fact that I see a GCF there in the numerator, so I'm going to take it out. This would be equal to 8 times x minus 2 over x times x minus 2, and you can see that that was important because we can cancel. We end up getting with a final answer of x over 8. Sorry, 8 over x. So watch out for that factoring at the, or watch out for reducing at the end, right? Reduce at the end. Always reduce. If you got an answer of 6/12, when you add, you need to reduce that to 1/2. Same thing goes with polynomials. Same thing goes with rationals. You got to reduce. Alrighty, so even with 3, the process is just find the LCM, apply it to everyone, and simplify the tops. And then if you need to, simplify the whole fraction, right? It's not a whole bunch of extra steps. There's just a few steps, okay? There's a lot of steps. Well, there's not even a lot of steps. There's just a lot of itty-bitty things to take care of, so don't let that overwhelm you. Go piece by piece, step by step, you'll be fine. Let's do 2 more. So I've got this one, m plus 4 over m squared minus 2m minus 3. Subtract 2m minus 3 over m squared minus 5m plus 6. Now remember, we're not changing division to multiplication, so I'm not going to flip the fraction. I'm just going to make this top one negative. But first, I think I'm going to find an LCM. Finding an LCM. We saw this a little while ago. Finding an LCM of a quadratic just means I got to factor. I got to factor it. I can't deal with stuff like this. It's too big. Got to factor these guys. M squared minus 2m minus 3. M squared minus 2m minus 3. Let's see. That would be two things that multiply to negative 3 and add to negative 2. Thinking negative 3 and 1. Negative 3 and 1. Yep. So this would be m minus 3 and m plus 1. Again, 6.3 or 6.2. 6.2. So that was this guy. The next guy, I have m squared minus 5m plus 6. Yep. Two things that multiply to 6, add to negative 5 would be minus 2 and minus 3. Alright, minus 2 and minus 3. So what's their LCM? The LCM is going to be the thing they have in common. The things they have in common. Yep. Let's see. They need an m minus 3 and an m plus 1. Here, he already has an m minus 3, so really all I need is an m minus 2. Alright, I grabbed one of each. Sweet. Next up, I will convert both of these to one fraction, right? So I have now, instead of this, I'm going to rewrite it as this. I'm going to rewrite it in factored form. So now I have m plus 4 over, instead of this horrible fraction, I have what was, or sorry, polynomial, I have what was, I just factored to. So m minus 3 and m minus 1, right? Being subtracted from 2m minus 3 over what I just factored it to, m minus 2 and m minus 3. Okay. So that looks a little better, right? That looks a little better. I'm going to switch. Okay, so I'm going to take this one at a time. What's missing from the first one? What's missing from the first one? That m minus 2, right? I have the m minus 3, I have the m plus 1, I don't have an m minus 2. So I'm going to have to multiply this first guy, m plus 4 over m minus 3, m plus 1. That's what it was originally. I have to multiply it by m minus 2 over m minus 2. Awesome. And then this second guy, you know what, we're only going to do one more. If you want to try this one out at home, go for it, but we're going to do one more. The second guy, I'm going to subtract this whole thing, right? Well, yeah, I'm going to subtract the whole thing. So I have 2m minus 3 over m minus 2 and m minus 3, right? That's the original one. What's missing? The m plus 1. So times it by m plus 1 over m plus 1. Okay, so far I've actually done nothing. I've just figured out what's missing in both of these, right? I'm just multiplying by what's missing. So the pink part now becomes, let's see, m times m plus 4 times m plus 2. That would be m squared minus 2m plus 4m minus 8 over, I'm going to put it over 1. No, yeah, I am. No, I'm not. M minus 3, m plus 1, and m minus 2. Again, I'm not multiplying the bottom. You can. You're more than welcome to. But I'm not going to right now, just because I don't feel like it. And then over here, we have this one times this one. So that would be 2m squared. I guess we'll do it in the same color. So 2m squared plus 2m minus 3m minus 3 over still the m minus 3 m plus 1 m minus 2 LCM, right? Those two are being subtracted. Okay, so now I will subtract. So I can change all of these signs to negatives. They're negative versions. So now I'm adding a negative, oops, helps if you remember what they were to begin with. So I'm changing this to an adding, a negative here. This one becomes a negative. This one becomes a positive, that becomes a positive, right? So adding the negative version. And we end up with the final answer. Same denominator. I have not touched the denominator since I decided it was going to be this based off my LCM, right? I didn't touch it. I left it alone, right? Same. The only thing that's changing is I'm multiplying the things in the top. So now I've got all these things on top that I can combine. I have an m squared and a negative 2m. That gives me a negative m squared. I've got 2m, negative 2m, 4m, that makes 2m. Here I've got negative 2m and 3m, that makes 1m, so plus 3m. And I've got negative 8 and 3, that's minus 5. Okay? Let's see, anything? So I'm going to take some space over here for just a moment. I'm going to try and factor this guy up at the top here so that it can see if anything cancels. I'm not sure it will. If I take out a negative 1, I've got m squared minus 3m plus 5. Does anything multiply to 5 and add to negative 3? 5 and 1? No, it does not. So this is my final answer. Since the top one is prime, this is my final answer. Alright. Again, lots of work, not lots of thinking, not lots of math. Okay? It's find the LCM, multiply it to whatever you're missing, multiply by what's missing, and then multiply the tops, combine like terms, you're done. Okay? There's only like 4 steps. Just takes a while. Got to keep organized in your brain. Again, if you like to use the colors like I do, use the colors, man. Break out a set of colored pencils during the test. I'd be totally okay with that. In fact, it might look even prettier. I would love that. I may hang it up on the wall. These things are only complicated if you let them be complicated. If you let them overwhelm you, you will always lose. Make sure you treat them like Jack Black, right? Do not treat them like Dwayne "The Rock" Johnson, okay? They are not here to hurt you. They can't hurt you. They are soft and squishy. They are large, like Jack Black, but he will not hurt you. He can't, right? It's just Jack Black. So go piece by piece, and you'll eventually get down there to the answer. Alright, that was 7.2, adding and subtracting. You have a homework. Hopefully that helped answer your questions. Otherwise, feel free to email me. I'll see you next time.